Let's start this lecture. In this lecture, I will quick revise inversion of 4-bar and double slider. Because some students ask for better understanding, sir, give the animated mechanism. So I have put some mechanism. I will explain how the degree of freedom, how links are connected. So this is a revision lecture. Okay, so I will not going to in deep, because you can check my main video, which is already sent in your. Okay, let's start. So this is the beam engine, also known as a crank and lever. So you can see here there is a crank is rotating. In our case, there is a crank is rotating. Crank is connected to connecting rod, and connecting rod is connected to this lever, and lever is connected to piston rod and piston. But when we are, sir, there is a, it is the inversion of 4-bar, sir. So why there is a piston? It should be in a single slider? No. When I am saying that in this mechanism in our book, this portion after lever is not considered as a link. You can see the number is not given. Okay, so as you can see, link number 1 is a frame, link number 2 is this crank which is rotating, link number 3 and link number 4. Up to these 4 links is considered in this particular mechanism. Piston and piston rod and this cylinder is considered as a extra links, because we are here what we get by the 4-bar. In 4-bar we give the rotary motion to one link and oscillating motion we get. Okay, so in this particular mechanism, rotary motion is converted into oscillation of this lever. Okay, piston rod and piston is considered as extra. Okay, you can see, first of all, let's count the number of pair. So first of all, you can see there is a number 1, crank and fixed is a pair, and crank and connecting rod, this is the pair number 2. First pair is at center, 2, 3. Okay, and this lever is connected to this fixed point. So this 4 pair and all are turning. Okay, so that's it. Let's go to next. So this is the second inversion of 4-bar, which is also known as a double crank. Why double crank? We already know that in double crank there is a 2 element which are rotating. So that's why. And you can see here the power of this engine comes to rotate this wheel only. But rotation of this wheel is transmitted to this wheel by this coupling rod. And that's how this mechanism is known as a coupling rod of locomotive, because it transmits the power of one main wheel to the other wheels. Okay, so this is the animation of that. You can see here, it is also known as a double crank. Okay, so this is the double lever, which is known as a Watt's indicator. Okay, this is not Watt's indicator. I have this example which is same as the Watt's indicator. What is here? If this is the mechanism which is used to enlarge the drawing, you are drawing here and it is enlarged by at this end point. And same if you put draw here straight line, and then straight line will be drawn here. Same as here, you can see this piston wheel, if piston this reciprocate in a straight line, what will happen? This straight line will be enlarged. This minor displacement of piston will give us larger distance. Okay, and it's indicate also. So same, it is the same as Watt indicator. Okay, this is not in this animation is not Watt's indicator. Let's start the inversion of double slider. In double slider, first inversion is a elliptical tremble. So you can see there is a 2 slider is here, 1 and 2, and in this case you can see here this is the slider number 1 and second is a slider number 2. One is a horizontal, second is a vertical, and as you can see this is a P point is here for drawing the elliptical. Same as in this link, there is a P point is put it outside of this link. Okay, so we can find the larger ellipse. So you can see the animation as you, in this case, as you select the other point, the ellipse you will find will be different. At different point, if you put point here and consider this, the elliptical view you will find will be different. So different size of ellipse you can find. It is totally depend upon this distance. As you go further, ellipse will be larger. Okay, so this is the elliptical Dremel. Second is a Scotch-Yoke mechanism, and as you know, in Scotch-Yoke mechanism or all other mechanism of double slider, there will be two sliding pair. And which are the two sliding pair here? You can see there is this element which is sliding between this path, and due to that it is not sliding, actually it is rotating, but it has to move in further direction. It pushed this blue rod in this direction, and we see that it is sliding upward direction, but it is actually rotating, and it will push this rod in this direction, and this slider is sliding inside the cylinder. Okay, let's check this. So you can see here this element, this green dot will rotating, and it pushed this rod in this to and fro direction, reciprocating. So there is a two sliding pair we can consider. One is between this green dot and this bar, slotted bar, and second is between piston and this rod. That's how there is a double slider. Okay, so last our inversion is a double slider. In double slider, always there is a driver shaft and driven shaft, and there is a lateral misalignment is there, small lateral misalignment, and between that you can see there is a green part is there. In this green part there is a two projected slots are there. So one projected will be go in a driver side, and second is, you can see here, this is in a driven side. You can see, check this. Okay, and it will slide between both red and yellow in these colors. This green will slide in both elements. Okay, so that's it. Okay, these are the double slider crank mechanism. In 7 marks, all three draw and explain, and also ask in 7 marks explain any two in detail. So that's type of theory also asked in this, from this chapter. Okay, some student ask for the okay, some student ask for the more example of Kurzweil equation and some higher pair. So I will solve some GTU questions and some from the RS Khurmi. Okay, let's start for this. Okay, so you can see from this figure the number of link is already given. So link number 1, link number 2, link number 3 will be link number L is. So how many joints is there? J is equal to lower pair and H is equal to higher pair. Means joint, we have to find the, first of all, which are the joints. So first of all, you can see 2, between 2 and 1, this is the point. So this you can see here, this link will oscillate when this is rotating. So you can see here, this is the joint number 1. Okay, and this 3 is also rotating with respect to this. So here the two lower pairs are there. Okay, and link, number of link is 3, but one higher pair between 2 and 3. Okay, here is a point or line contact is there. Okay, when the some surface is touching on some disc, there is a line or point contact, so one higher pair is there. Okay, so this equation is became like this, 3 into 3 minus 1 plate minus 2 into 2 minus 1. So what will happen? We put in this equation 3 minus 1 into 6 minus 4 minus 1. Degree of freedom will be 1. Okay, so final degree of freedom will you find is a. So link number 1, link number 2, link number 3, 4. Number of links is already given. So in this total triangle, there is no relative motion between them. So they are considered as a single link. Okay. So link is 6. How many joints are there? Is a no higher pair, because higher pair means line or point contact. So there is a higher pair is a 0. Okay. Higher pair is equal to 0. What is a joint? Number of joint? So 1 here, between 1 and 2, between 2 and 3, between 2 and 5. This is all a turning pair because they are turning with respect to other. So these joints are turning pair. So number of joint J is equal to, you can see, count this 1, 2, 3, 4, 5, 6, 7. Joints are 7. What will be this equation? 3 into 6 minus 1 minus 2 into 7. So it will be 15 minus 14. So degree of freedom is equal to 1. If you push this mechanism in this direction, this whole mechanism will move. So degree of freedom 1. There is no other requirement. If you want this link, this link in this direction, there is only one input is required. Push this link, or you can push any one link, and this mechanism will reach in this condition. Okay, next. Okay, so this is a very tricky and very important example for the Kurzbach, because there is a higher pair and there is a roller. When there is any roller on a surface, there is a possibility of sliding. So first of all, find the degree of freedom. So check this, there is a 1, 2, 3. This wheel or roller is a link number 4. So how many 4 links are there? How many joint? First is there is a turning pair between 1 and 2. Between 2 and 3 there is a turning pair. 3 and 4, because this roller is rolling with respect to 3, so 3 turning pair lower, and there is a point contact between this wheel and this surface, there is a 1 higher pair. So if we put this here 4, here 3, here 1, what we get? We will get 2. Degree of freedom 2. 4 minus 1 is equal to 3. 3 into 3, 9. 9 minus 6 minus 1. So this will be 7. 9 minus 7, this will be 2. So why there is a degree of freedom 2? And how it is possible? Okay. So first of all, check this. If you try to rotate this wheel, okay, why there is a degree of freedom 2 here? Consider, and you can see in book, there is a note is given in a book. If there is a friction is less, there is a chances of this wheel on a slipping, means a slippage is possible in this case. So how it is possible? So consider this. If I want to move this link in this condition, if I rotate this wheel, what will happen? If there is a enough friction, sufficient friction is there, it will rotate and it push this connecting rod, and this crank will be in this condition. But consider there is a oil is there, or this surface is very slippery. There is a possibility there this wheel is rotate on itself, means this will only rotate, not move further. Okay, and that's why you have to give also motion to this in this direction, so that this crank is moved. There is a 2 inputs required if there is a no friction or very less friction is there. So that's why degree of freedom is 2 here. Okay, because whenever there is a wheel, and it is rotating on flat surface, there is a possibility that it is not move in this direction. It is rotating only on that point. Point will be here and it is rotating on the same point. There is a possibility that, so that's why there is a degree of freedom. Okay. So this is are some inversion of double slider, and they are asked for degree of freedom. And always consider, remember that in our all inversion, 11 inversions we have studied, and in all that degree of freedom is 1. Okay, remember that, it will be useful. So check this, the number of links is already given here, 1 2 3 4 4. How many joints are there? So check this, this 1 is fixed and 2 number is a crank, so there is a turning pair. You can check here, this is the turning pair 2, and this slider inside this. Okay, this is the third number link, and you can check this, there is a turning pair is here between 2 and 3, and 3 and between 3 and 4 there is a sliding, because it is sliding inside this slider. Okay, so 3 and 4 there is a sliding pair, and 4 is sliding inside this cylinder, so sliding pair is there. 2 sliding, 2 turning, so joints are 4, links are 4, degree of freedom is 0. Okay, so that's it. This is the basic examples of for the degree of